This is my experimental project for the CHBE101 class. The topics covered in this project include gas-liquid phase systems and the psychometric chart. What I did was I went to three cities, Frederick, College Park, and Gaithersburg, and found the temperature and humidity of each of the three cities at any given time. This is the tool I used. It's a hygrometer, which counts as both the thermometer and a hygrometer. The hygrometer is what measures humidity, and the thermometer is what measures temperature. And the margin of error for this is plus or minus 2 degrees Fahrenheit and plus or minus 5% humidity. So what I did was I went to each of the three locations and stood outside for a couple minutes and let the readings adjust and stabilize. I then recorded that in the form of data points where the temperature recorded by the thermometer is the dry bulb temperature, and the humidity recorded by the hygrometer is the relative humidity. And using these two data values, we can determine all of these other data points. And then I used further calculations to determine the degrees of superheat, vapor pressure, and molar fraction of water. So as you can see here for Frederick, for example, the dry bulb temperature was found to be 41.8 degrees Celsius, which I had to convert to Celsius from Fahrenheit. But then using these additional guidelines, I was able to find the exact point that this lies because the relative humidity was found to be 45%. So I would find where along this curve is the 45% line. And that gives me all the other values, which are the wet bulb temperature, the absolute humidity, which is the y-axis here, the specific enthalpy, which is the pink diagonal lines, the humid volume, which is these green diagonal lines, and as I said, the wet bulb temperature is the blue diagonal lines. And then using these, and then find the dew point, which is the line along the same y value at which relative humidity is 100%. So it's this bold line. And for Frederick, it would be the point on this line where the absolute humidity is the same as 0.0233, which in this case is 20.6 degrees Celsius. And then subtracting the dew point from the actual recorded dry bulb temperature gives you the degrees of superheat. And then using additional calculations and data lookups, I was able to find vapor pressure using table B3 in the FRB. And by dividing this vapor pressure by the atmospheric pressure, I can find the molar fraction of water using Dalton's law. Something else I did was that I also compared the results I found to the accepted data from a website called Weather Underground, which pulls from actual weather services like the NOAA and the Weather Channel. And this are the data points it found for temperature, humidity, and dew point. And then I was able to use the same methods above to find degrees of superheat, vapor pressure, and molar fraction of water. And all in all, I found that there is like a pretty sizable difference between the data values. I think this is largely because of the fact that the tool I used has a pretty large margin of error, especially for humidity. Plus or minus 5% is a pretty big margin of error for a device like this. So this is what resulted in these large differences in data. Another possible issue is that weather readings aren't accurate down to like a very specific location. It's possible that my location at which I recorded the data points has different temperature to what the weather website or weather app would give, because that Weather Channel or something that would give weather readings for that entire city and not just that specific point at which I'm at. This experiment is very easy to replicate. You just drive to it or just drive to another city, use one of these to record the temperature and humidity, and store that into like the spreadsheet, for example. There's very little safety risks. However, if it is extremely hot outside, for example, as it was in Frederick and Gaithersburg, I would suggest against staying outside for too long because it could lead to heat exhaustion or other related effects.